When our client started this project, they were asking for the development of an 8-megawatt turbine, which is, at the time, the largest turbine in the world to ever be designed and manufactured, that would run uninterrupted for 25 years. We're talking about the North Sea. Very remote, hard to get to, so it had to be reliable. They weren't looking for a supplier, they were looking for a partner, and they needed someone that would have unparalleled manufacturing and engineering technology. We have an in-house analytical modeling tool, and we are able to take all the varied wind conditions that the customer supplied, and through that analytical model, we came to a conclusion together this would be 2 dissimilar tapers on the main shaft configuration. The largest bearing being just over 2 meters in diameter, and the smallest bearing being just under 2 meters. But the key is they were designed specifically for the application. One of the key specs is the swept area of the turbine, and that would be the diameter of the rotor blades. And it was 164 meters in diameter. And the way that translates is the blades now became 80 meters in length. The Boeing 747, from the back end to the nose, is only 70 meters. So you can envision 3 Boeing 747s rotating around this hub, 35 stories above the ocean. This swept area creates a tremendous amount of power. Our bearing is the linchpin between the raw power that's harnessed from the blades of the North Sea and also the generator behind the main shaft configuration that's generating the 8 megawatts of power. In offshore wind energy, because of the massive size, you don't have time for physical testing. We just opened up recently our own wind test center. This is a massive test center, and it allows us to test up to 4-meter bearings and test offshore applications. We simulated the 20-year lifetime in 5 months of testing. Then the next step was to figure out, how are we going to make this? Our traditional heat treat process in our case carburized bearings is to put them in a large pit furnace. And for this size bearing, what we found is we'd have to put that in the pit furnace for 2 to 4 weeks. And we started working on an innovative, seamless induction technology that allowed us to take a 2 to 4 week process down to 5 hours. After we installed the bearings and put them in place, the generator, along with the main shaft configurations, get assembled into the nacelle, and the nacelle now has been delivered out to the North Sea, has been erected on top of the tower. When we plug that in and we push the button, immediately that turbine is going to be connected to 3,500 homes. As the Timken company, we don't only focus on the beginning and the middle, but we focus through the entire life cycle of the project. So we intend to be engaged with our customer for the next 25 years, servicing them on that turbine. Timken is a solution provider that takes our customers' most challenging conditions and turns them into opportunities.